Students, after a long time, again I am in front of you, and now I am going to start chapter 10, wave optics. We already completed ray optics. So there is a difference between ray optics and wave optics. So while we discuss the ray optics, we don't consider light is a wave. So it doesn't have any wavelength. Wavelength is considered to be 0. It stands to 0. So now we are discussing wave optics. So there is a role of the wavelength. Role of the wavelength. In ray optics, we say that light travels in a straight path. And you must have performed the experiment of postcard. Suppose one source of the light is here, okay, and we put the postcard. In fact, we also performed this experiment in my village, and we have a teacher, Manu Bhai Rajyaguru, who has demonstrated this. They asked us to bring the postcard from home, that is used postcard. તમારામાંથી ઘણા જોયા બી નહીં હોય તો. And there is a holes. So if these holes are in a line, then we can see this light here. Okay, we can see this claim. And when the postcard is displayed, so you can't see the claim. So that is the light travels in the straight path. That is the ray optics. But in this present chapter, we will discuss. See, suppose in the room, no light glowing and a window is open, so whatever the light of the sun is also we are getting inside, not directly but indirectly. Okay, so that is the concept of wave optics. So light has a wave. For that we have few experiment, that is the interference, then diffraction and polarization. These are the three phenomena we observe in light and can be explained. We can observe, but can be explained with wave theory. If you consider light as a wave, then and then you can explain these three phenomena. You cannot explain with ray optics. So in present chapter, we will discuss interference, diffraction and polarization. And to explain these three phenomena, we need to explain certain thing which is the base of our rest theory. Okay. So if you see the text, so in the first page, you can see that introduction. Many students are not reading or taking not much interest in introduction. મારે એમને વોર્ન કરવા છે. Please read each and every line. You try to understand. Sometimes questions are asked very straightforward from the text itself, direct line, and you are working very hard to solve big problem, time consuming, brainstorming, but you are not reading a very simple line, and because of that we are losing the marks. So beginning, introduction, you must read it. You have to mark important lines, important words. Okay, few of things I tell you. In the beginning, it was believed that, we know that when you have a rarer medium and you have denser medium, and when light is entered from rarer to denser, what is happening, that we know, we already discussed in ray optics. So it deviates toward the normal. If this is rarer, then it goes away. So in corpuscular theory, it was believed that when it bends here, the velocity here, so I say v2, here velocity I say v1. So according to corpuscular theory, v2 is greater than v1. v2 is greater than this v1. And it is supported by Newton also. v2 is greater than v1. But after the theory given by Heisen, see, we are talking of 17th century. 17th century, almost in 1670 aspas. You can read it. What he has given theory, and according to this theory, V2 is less than V1. V2 is less than V1. If light ray deviate toward the normal, means velocity is less. And this is the fact. This is the fact. તો ઘણાને એમ થાય કે આ ગપ્પા હતા, તો ઘણી વખત I tell you, many things are developed on the basis of previous one. Last edition ઉપર new edition જ આવે, direct new edition ન આવે. તો આમાં એનું contribution છે જ, પણ પછી હાઇજને એનું correct કર્યું. So if light travels from denser rather to denser, velocity decreases. V2 is less than V1. V2 is less than V1. Okay. So this type of discussion is given in introduction. So I again tell you, please read each line and mark it. જેથી કરીને એમાંથી જો ક્યારેક ક્વેશ્ચન આવી જાય તો તમારે કહીએ ને એક લોટરી જેવો પ્રશ્ન બની જાય, અને આવું બને છે, ઇટ હેપન્સ. તો ઇન્ટ્રોડક્શન તમે જોઈ જોઈએ. See, when this theory is given at that time, suppose we want to send one wave from one place to the other place. Suppose we have here one string is there, and we give some wave. So wave is propagates in the medium. Okay. So at that time, it will believe that to propagate the wave, we need the medium. But after the theory given by Maxwell, and Maxwell we are enjoying this communication system. Maxwell, he has given, actually he has unified 4 formal equations called Maxwell's equation. He proved that wave can travel without medium also, that is the light wave. Because sun rays are coming from sun and reaching to the earth, there is no medium between earth and sun. So it means that wave can travel without medium, and it is shown by the Maxwell. So light is nothing but one type of wave. It is called electromagnetic waves. Electromagnetic waves. So there is electric field vector and there is a magnetic field vectors. Both vectors are oscillating at a given point. Electric field oscillates how the magnetic field generates the magnetic field oscillates electric field generates that. We are not discussing in details, but this is the fact. Light is electromagnetic waves. It doesn't require medium. And in vacuum, all the waves with different wavelength have same velocity. But when it enters in the medium, so different wavelength has different velocity because velocity is equal to f lambda, where f is the frequency and this is the wavelength. Okay. So when you change the medium from this medium to medium, velocity change. Frequency is the property of the source that you must be knowing. We cannot change the frequency. Frequency is the property of the source. एक वक्त frequency बाहर आवी गई तो आवी गई. You cannot change it. Wavelength can be changed by changing the medium. Okay. So when a wave travels from one medium to the other medium, velocity gets changed, wavelength gets changed, frequency can never change, and amplitude also can be changed. તો આ બધી વાતો જે નાની નાની છે that is discussed in introduction. તો મારે તમને again I insist કે તમે line to line read કરજો. Okay. Next topic now I am focusing, that is Heisen's principle. Heisen's principle. Heisen's principle. Okay, that we are going to discuss. Heisen's principle. To explain Heisen's principle, first I discuss about wavefront. Wavefront. What is wavefront? Suppose I take one stone and I drop it in a still water. Water is stationary. I put in the stone. And તમે બધાએ જોયેલું જ હશે. શું થાય છે? So when stone enters and surrounding to that hitting point, you will get the rings. રિંગો જોવા મળશે. And if you take the photograph for one instant, so you will see such type of rings. આવી તમને રિંગો જોવા મળશે. So whatever the disturbance is created here, it propagates in the medium. This side, all the sides. Okay. So this point and આ બાજુનું point, આ બંને point પાસે disturbance એક સાથે પહોંચતો છે, means all the points on the circle. Disturbance is reached at the same time. Means this all points are oscillating. These are oscillating with the same phase. All the points on the ring are oscillating in the same phase. So locus of this is called wavefront. In other words, we can say that an imaginary imaginary surface passing through the points or particles are oscillating in same phase. આમ બી કહી શકીએ. અથવા તો locus of the point oscillating in the same phase called wavefront. So shape of the wavefront depends on what? Shape of wavefront depends on type of the source. Depends on type of the source. Instead of one stone, point like if suppose you have one road, it is placed or dropped, then you will get wave. આવી રીતે wave આવશે. Plane type. Okay. But if you go very far from the source, હું અહીંથી ખૂબ જ દૂર જતો રહું, big circle and big circle. So if you take the small part of that, see it is in 2 dimensional, it is circle, but if it is 3 dimensionally, suppose here is the source and it's moving all the direction, then it is spherical. If it is tube-like, suppose here I am talking about the electromagnetic waves, it is tube-like. So waves are like a cylinder. If bulb, then it is spherical. અને અત્યારે આપણે કહીએ ને કે પેલી લાઇટ આવે છે ફોકસ, ઘણા બધામાં LEDs લગાવેલા હોય, તો એમાંથી આવે છે પ્લેન ટાઈપ. So if you go very far, spherical છે, but if you take small part of that, it is a plane type. So whatever the type of the wave front, if you go very far from the source, then it looks like a plane type. So any type of wave, wavefront at large distance, it looks like or it seems that plane type. આપણે એમ કહીએ કે સનમાંથી લાઇટ આવે છે સન અર્થ સુધી, તો એ બધા વેવ ફ્રન્ટ પ્લેન જ કહેવાય, કારણ કે sun is very far and we are talking for the very small area. Okay. Shape of wavefront never change. ક્યારે? એ પાછ condition for homogeneous isotropic medium. Homogeneous and isotropic medium. તો તમને એવું થશે કે what is this isotropic homogeneous medium? I give one simple example. Homogeneous means what? If you add sugar in the milk, it is not homogeneous. But if you add the sugar in the milk and stir it till it melt completely, dilute, dissolve થઈ જાય, not melt but dissolve થઈ જાય, then it's called homogeneous. Then what is isotropic? What is the meaning of isotropic? તો હું વિલેજનો છું, એટલે I just many times I give the example. તમે ચણી બોર જોયેલા હશે, જેને જોયા હોય એની વાત કરું. ચણી બોર, તો ચણી બોર જ્યારે આપણે લેવા જઈએ ને તો અંદર હાથ ઘૂસી જાય ખરો ઝાડની અંદર, છોડની અંદર, પણ બહાર ના નીકળે, કારણ કે એના જે કાંટા હોય છે એ આવી રીતે વળેલા હોય આમ, તો અંદર જાય તો આપણે વાગે ને, બહાર કાઢી ત્યારે વાગે. તો ઇટ હેઝ ડાયરેક્શનલ પ્રોપર્ટી. આમ જોવું ઇઝી છે, બહાર નીકળવું મુશ્કેલ છે. So it is It is not isotropic. Isotropic means whether in this direction or that direction, meaning is same. હું લાઇટ અહીંયા રાખું અને અહીંયા આગળ રિસીવ કરું, વોટ એવર ધ ટાઈમ ઇઝ ટેકન, લાઇટ અહીંયા રાખું ને અહીંયા રિસીવ કરું, ટાઈમ હરખો લેશે. જો હરખો લે તો આઇસોટ્રોપિક કહેવાય. ઇફ ઇટ ઇઝ ડિફરન્ટ દેન ઇટ ઇઝ નોન આઇસોટ્રોપિક. તો જે બધી બાજુ જો મીડિયમ સાઇઝ હોમોજીનિયસ હોય અને આઇસોટ્રોપિક હોય તો વેવ ફ્રન્ટના શેપ ચેન્જ ના થાય, નેવર ચેન્જ. બટ સપોઝ આઈ સે this is a bulb. Suppose I take a bulb હું લઉં છું, this is bulb, and this side I take glass, and this side I say air. તો આ બાજુ ડિસ્ટન્સ વધારે કવર કરશે, આ બાજુ ડિસ્ટન્સ ઓછું કવર કરશે. તો this point and this point are in same phase. આ જ્યારે અહીંયા પહોંચે તો અહીંયા પહોંચે, and if you connect all this thing you will not get the spherical shape. તો તમને જુદો શેપ બદલાઈ જશે. So you can say that shape is all get changed because of medium is changed. Okay. What is the phase difference between the 2 points on the wavefront? Yes, 0. Yes, 0. Phase difference between 2 points on same wavefront equal to 0. But if points are on different wavefront and distance is suppose x, એક wavefront અહીંયા છે, બીજું અહીંયા છે, અને અહીંયા એક point A છે, અહીંયા point B છે, આની વચ્ચેનું distance x છે. So what is the phase difference? Yes, if the distance is lambda, phase difference is 2 pi. If distance is x, then how much? આપણું જૂનું વેવનું ચેપ્ટર તો એમાં આપણે કરેલું છે, યાદ છે તમને? તો ડેલ્ટા વિલ બી 2 pi upon lambda into x. તો આવી રીતે યાદ કરવાનું. પણ if one point is here and the second point is here, તો આ બે વચ્ચે phase difference 0 because both points are located on the same point, same wavefront. કન્ફ્યુઝ કરવા માટે ક્વેશ્ચન એવો તમને મેં શીખવાડ્યું છે તો તમને આવી કેલ્ક્યુલેશન કરો. નો, if points on the same wavefront, phase difference is 0 કારણ કે according to definition of the wavefront it is there. Understood? તો આ વાત થઈ wavefrontની. Wavefrontનો shape depends on source. Also you can say that it depends on medium. અને જો તમે ખૂબ દૂર જાઓ તો small part looks like a plain wavefront. Okay? Okay? So again, disturbances are given here. So you are giving some energy here, and this energy is spread in all directions. બધી બાજુ જવાની છે. So you can see the energy going this direction. This is the wavefront. So energy is transmitting always perpendicular to the wavefront. Energy આમ જાય છે, આ એનું wavefront છે. Energy આમ જાય છે, આનું wavefront. So energy is always transmitting perpendicular to the wavefront. If it is a light wave, તો આપણે એમ કહી શકીએ કે આ ray બની ગયું. This is nothing but ray. So ray is always perpendicular to the wavefront. Ray is perpendicular to the wavefront. And now we go for the Heisen's principle. Now we go for the Heisen's principle. Suppose you have a source here and આ એક wavefront તમારી પાસે બની ગયેલું હતું. This is the source and I say this is F1, F2 is my wavefront at given time t equal to 0. At t equal to 0, shape of wavefront is like F1, F2. આવું આપણી પાસે છે અત્યારે. Now, using Heisen's principle, we can determine position of the wavefront after a certain time tau. So, what is the position of wavefront after time tau? તો મારે શું કરવાનું? તો according to Heisen, each point on the wavefront is a source of secondary wave. દરેક પોઈન્ટ છે એની ઉપરના સેકન્ડરી વેવ છે, સોર્સ સેકન્ડરી સોર્સ છે, which emitting secondary wavelets in 3 dimension. આ દરેક પોઈન્ટ છે એમાંથી વેવ જનરેટ કરશે in all direction, means in 3 dimension. What is the velocity? With the same velocity, that's the velocity of the wave. With same velocity, that's the velocity of the wave. તો મારે tau ટાઈમે જોતી હોય તો how much time is, how much distance is covered? તો આ પોઈન્ટ હું કહું તો આમાંથી એક સેકન્ડરી વેવ નીકળી ગયું, આ મારું વેવ નીકળી ગયું. અંડરસ્ટુડ? તો આ ડિસ્ટન્સ કેટલું હશે? તો કે વેલોસિટી ઇન્ટુ ટાઉ. અહીંયાથી એક હું વેવ બનાવી નાખું. ઓકે, આઈ હેવ ટુ મેક એ સ્પેરિકલ, પણ થોડીક બનશે એવું. Again, what is this distance? That is velocity into tau. So if you take all these points as the secondary source તરીકે મારે લેવાના, એમાંથી બધા વેવ ડ્રો કરવાના, and if I draw the tangential surface to this અને tangential surface draw કરું, so that is my f1 prime f2 prime. That is my second wave friend after time tau. Okay, if this is non-isotropic and homogeneous, તો velocity અહીંયા જુદી હશે, અહીંયા જુદી હશે, બે સરખી, radius will be different. So in that case, shape of the wavefront will change. Understood? So likewise, you will have more wavefronts. એકમાંથી બીજું, બીજામાંથી ત્રીજું, and so on. So this is explained by the Heisen. Each point on the wavefront acts as a source of the secondary wave and emitting secondary wave called wavelengths, and tangential surface to this is new wavefront at a given time tau. અહીંયા tau કીધું છે. So same look, in same way, here we have explained for the spherical wavefront. It is a cross-sectional view actually. This is a cross-sectional view. If you cut any sphere, it looks like this, a hemisphere. We can explain for plane wavefront also, same theory. Then question comes, why it is propagating in outward direction, not backward direction? It is always traveling in front direction, not in back direction. So that is also explained with wave theory, with complicated wave. But one thing is that it is not mentioned in the text. This intensity depends on cos square theta by 2i. Cos square theta by 2. Theta equal to 0, then it is 1. And here it is 90. So okay. And here it is, yes, it is cos, it depends on cos square theta by 2. So આ point મારે જોતું હોય તો theta is 0, so you get maximum intensity. આ point મારે જોતું હોય, this is my theta. If I want to see this point, then it is 90, so it is 45 and so on. This is not mentioned in our text, NCERT book, but it is mentioned in old text, that is Gujarat Board text. But this can be explained. It is explanation is not given in the text, but okay, we can explain it. Why it is not propagating backward direction? Heisen principle બરાબર છે, પણ backward direction નો કેમ નથી આવતું એની explanation નથી. Wave theory થી આપણે આપી શકીએ છીએ. Okay, so this is concept of wavefront and how wave propagates. તો જેમ તમે દૂર જાવ તો શેપ નથી બદલાવાનો, જે શેપ અહીંયા હતો એવો શેપ અહીંયા છે, એવો શેપ અહીંયા છે. You go away, then also shape. But if you take small part of that, then it looks like a plane type. એવું આપણે ચોક્કસ કહી શકીએ. Okay. So we explained wavefront and propagation of the wave using Heisen's principle. This question can be asked in theory form. Okay, and a very small question, as I told you about the phase difference. Okay. In next topic, we already explained refraction and reflection in ray optics. But same theory can be explained using Heisen's principle also. We can explain. So that is also important theory, and that we'll discuss in the next chapter, next lecture. ઓકે, થેન્ક યુ વેરી મચ. ફરી વખત તમારે ફ્રેન્ડ્સ બરાબર આગળનું રિવિઝન કરી કાઢજો રે ઓપ્ટિક્સનું. એમાં કંઈ મુશ્કેલી હોય તો યુ કેન આસ્ક મી. ઓકે, થેન્ક યુ વેરી મચ.